13th class, I believe so. So last time we spoke about status check, and we discovered that status check, I gave you the notes. The notes are with you. Did I give the notes? If I did not give the notes, I think the notes will be given today. We discovered that status check is the resource that we use. We make use of it when we want to see and troubleshoot where the problem is coming from, whether the problem is coming from AWS or the problem is coming from our configuration of the system. So that was status check. And now there was a way by which we could set up alarms, when there is a problem at the level of AWS. There is little that we can do. When there is a problem at our own configuration level, we could set up alarms so that our machines can reboot automatically, because the solution for solving a problem of wrong configuration at your end is to reboot your EC2 instance. So we could arrange in such a way that we set up alarms that can reboot our instances automatically when there is an instance status check. Remember that we said instance status check is all about our EC2 instance, while system status check is all about AWS. So today we are going to be looking at three different things. The first one is protecting our instance from termination. This is going to be a very easy one, protecting our instance from termination. The second one is going to be we are going to look at the scaling up and scaling down. How can we scale up and scale down? And we are going to finish with actually practicing the scaling up and down with the elastic block store. So these are our duties for today. So let us first of all begin with protecting our instance. What is the meaning of protect instance from termination? Generally in the IT industry, we are always like trying to give a double check on any delete or any termination clause. If you are supposed to code anything, or if you are supposed to program anything at the level where there is delete or at the level where there is termination, you should make sure that that place should be well protected, such a way that if there is a delete, it goes directly to a recycle bin before it finally gets terminated. Now when you are in the industry, there are some particular machines. Take for example, you are following up a machine. You have a follow up on a machine on an EC2 server that is supplying internet all over maybe a particular airport, where that EC2 instance, if somebody actually mistakenly terminates that EC2 instance, everything goes down. So how can you do for that type of an instance to be protected from being terminated? That's what we want to do, because sometimes some people just get into the system. Since you are using the system with so many people, somebody gets into the system and then set up an EC2 instance and then wants to terminate that EC2 instance, and then he discovers that he instead terminated a server that is actually live. So how can you protect your servers from being terminated? That is what we are looking today. So let's try and go into our servers. Let us create an EC2 instance and then we protect it. Let us create an EC2 instance and then we protect it from being terminated. We are going to use that instance for so many different things. I will name the EC2 instance as EBS 1. I would like to take Ubuntu. I like using Ubuntu because I was trained with Ubuntu. I allow T2 Micro. Look for a keypad. This is actually best system. Okay, that's cool. All of us know what I'm doing, so I don't need to be explaining anything here. I am looking for a security group that I created. All right, I launched my instance. All right, with the instance being launched, my target, what I want to do is I want to protect my instance from being terminated. This is my instance, EBS 1. The instance is found in US East 1C. This one will be taken care of when we are actually going into EBS. US East 1C, that is the availability zone, the AZ availability zone, US East 1C. So my EBS is already running. As my EBS is running right now, it is possible for somebody to just come and click here and then click instance state and then put terminate and then come and terminate it here, right? So but that is what I don't want. So what will I do? I will select my EBS. I will come to actions. This is all your steps now. I'll select my EBS. I'll come to actions. I'll come to instance settings, and then I'll come to change termination protection, and then I will enable termination protection here, and then I will save. Now I have protected my instance from being terminated by mistakenly, as you always put it. If somebody happens to come now and select my instance and then go to instance state and come down to terminate instance and actually does the termination, you will see a red light here that failed to terminate an instance. The instance that may not be terminated. Modify its disable apt termination and try again. So this shows that nobody can terminate this instance anymore. Okay, so you have already protected your instance like that. It can no more be terminated. As simple as that. If you want to remove the protection from your instance, you just click again the instance, you come back to actions, you go to instance settings, and then you come to change termination protection, and then you remove the enable and you save. Now somebody can terminate this instance without any problem. Somebody can terminate now the instance without no problem, right? That is the first thing we were supposed to do. Show us how to protect instance from termination. That's it. The notes are there for you, and as I've always said, always make sure that you yourself make your own notes from the lectures, because these notes are sketchy. So you make your own notes from the lectures that you are hearing. The explanation is more detailed than the notes. All right, now the second our second thing in this evening is scale up and scale down. Here we are going to talk a lot about scaling up and scaling down. Why are we going to talk a lot here? Because I have attended almost 6 interviews where the question of give differences between horizontal scaling and vertical scaling. how different are they? Talking about horizontal scaling and talking about vertical scaling. Okay, lately we did auto scaling. In auto scaling, what was being added? We configured auto scaling so that a particular machine should be added if there is high traffic. That is what we did. We configured auto scaling so that when there is high traffic, a particular machine is being added. Which type of scaling is that? Which type of scaling will allow you that whenever there is traffic, you have one machine. Whenever there is traffic, another machine gets added. Whenever the traffic increases, another machine gets added. Whenever traffic increases, another machine gets added. Which type of scaling is this? Is it scaling up and down or scaling out? Right? Is it scaling up and down or scaling out? So this type of scaling is known as, this is the auto scaling. This type of scaling, please, is known as, this is known as horizontal scaling. Horizontal scaling. Okay, horizontal scaling. If you see this type of scaling, it is known as horizontal scaling, and auto scaling is an example of a horizontal scaling. So if they ask you what is horizontal scaling? Horizontal scaling is scaling in which EC2 instances get added as need increases. As there is an increase in need, EC2 instances get added. You see, there was one instance. After, when there was need, another one added. After there was need, another one added. After there was need, another one added. That is horizontal scaling. Now we are talking about the opposite of horizontal scaling is vertical scaling. In vertical scaling, what will be happening? In vertical scaling, instead of EC2 instances being added, look at what will be added. In vertical scaling, when you are going to have traffic, not traffic, but load, because here we are talking about CPU, we are talking about the CPU capabilities, or look at the CPU capabilities here. We look at the RAM capabilities here, and then we look at the hard drive capabilities here. Yes, these are the three things: CPU, RAM, and hard drive. Okay, so instead of many machines being added with vertical scaling, the CPU and the RAM gets added when there is need. The elastic block store can also be added manually by you. So that one is horizontal scaling, and we have it both scaling out and scaling in. So when they ever ask you, when I am talking about scaling out, what am I talking about? Is it horizontal or vertical? Scaling out, is it horizontal or vertical? Scaling out is horizontal. When you hear of scaling out, when they ask you in any interview what is scaling out, they are talking about horizontal scaling. That is scaling out. Scaling out, it is horizontal scaling. Then when they are talking about that scaling out and scaling in, it is horizontal scaling. Then when they are talking about scaling up and down, scaling up and down, scaling up and down, they are talking about vertical scaling. So when you hear scale out, it means add more CPUs and instances. Scale out, add more instances. Scale up and scale down means you should increase the capacity of the CPU and the RAM. The capacity of the CPU and the RAM, increase it. That is scale up and down. Okay, so in the interview they always like to use these terms and confuse you. Please, I will repeat again. Scaling out is horizontal, scaling up is vertical. Horizontal scaling is adding CPUs, adding more instances, while vertical scaling is adding more RAM and CPUs, that is processors, to a particular machine. Okay, that is it. Now let us see how you can scale. Let us start with scaling up, because we have already done scale out. Scale out is auto scaling. We have already done it. So let us see how you can scale up and down. And in seeing how you can scale up and down, what are we going to be doing? We are simply going to be adding more compute capabilities to our EC2 instance. That means right now our processor is T2 Micro, which is 1 gigabyte of 1 gigahertz of CPU and 1 gigabyte of RAM. That is T2 Micro. 1 gigahertz of CPU, 1 gigabyte of RAM. Can you scale up that and have like 3 gigabyte of CPU? Let's say you want to have now 3 gigabyte of CPU and 1 gigabyte and 2 gigabyte of RAM. Can you scale up like that? No. You can only scale up in a scale according to how it is defined. The scales are defined from T2, Nano, T2. Let's get into the console, please. And you see. Okay. In order to scale up and scale down, the first thing you need to do is you have to stop your instance. That's the very first thing you do. Stop the instance. Alright. Instance state. You select the instance first of all. Then you go to instance. The instance is already selected here. Then you come to instance state. Then you come to stop instance. Okay. You first of all stop your instance. When you stop your instance now, make sure that it is totally stopped. Please don't just go start doing things. This is the instance. What is it saying? Stopping. It is not yet stopped. It is stopping. Okay. The instance is stopping. It is not yet stopped. Always make sure that you wait until it is showing stopped. The instance is stopped now. You can now select the instance. You go to actions. Instance settings. Excuse me. Just give me 1 minute, please. Yeah. Hello. Okay. All right, no problem. Danke. Okay. All right, no problem. Thank you. All right. I am back. Sorry, please. Sorry for the disturbance. All right. I was saying that when we want to add more processors to our instance, all we need to do is we select the instance first of all. You make sure that your instance is selected, and then you go to come to manage instance state. No, give me a minute. Not instance state. Instance setting, and then you come to change instance type. Change instance type, and then you will see T2 micro here, right? When you see T2 micro here, you can change now from T2. You remember that T2 micro is 1 gigahertz of processor and 1 gigabyte of RAM. So you can click here now. You will see so many configuration. You are going to choose the one that you want to choose. Okay. You might want, this is T2 micro, you might want to go to T2 small, or go to T2 large, or go to anyone. So let's go to T2 small, right? We go to T2 small, apply. Okay, our instance has changed. It is no more T2 micro, it has increased now to T2 small. Look at up here. The instance type now is T2 small. Okay, we are now at the level of T2 small. So we have, what have we done? We have scaled up. We have scaled up. We have added more processors and added more RAM. Okay, we have added an additional processor and added an additional RAM. Okay, that is scaling up. Now what can we also do? We can also add more hard drive. This is, let's put this one processor, this one is RAM, and this one is hard drive, HDD. So we have added our processor, we have added our RAM, because processor and RAM is configured in what we call instant type. So our hard drive now is what we are going to look at, which is what we call EBS, which is elastic block store. We can add one more EBS to our machine. Let's come to our machine. This is our machine, right? This is our machine. How can we add an extra EBS to our machine? We can create an extra EBS and then come and add to our machine. Okay, let's do that. Let's go to EBS. This is EBS here. We see volumes. We take our volumes, we come create a volume. We want to create a volume. It's for a general purpose. The size is too big. Create a volume of, let's say 4 GB. Create a volume of 4 GB. And where should the volume be created? US East what? You remember that you should create your volume in the place, the region where your machines are created. US East 1C. That was the availability zone. That was our availability zone, US East 1C. Now you come down. Do you want a snapshot of that volume? No. Do you want it encryption? No. I come down. Is there any tag that I really want? No, I don't want any. I don't want to tag anything. Okay, now what do? I create my volume. The volume is created. This is a volume that has been created. But as this volume is created, this is a 4 GB volume that has been created, please. A 4 GB volume. As the volume is created, is it already found inside my machine? Is this volume already inside my machine that I have? No. If I go to my instant type, my instances. Let me start this instance. Start back my instance. Pending. Our instance is booting up. Okay, it is running now. So what do? Our instance is running now. We have a volume that we have created. We need to take that volume now and attach to our instance. How do we do it? We have to take the volume and attach to our instance. There are two ways of doing that. The first thing is that you are going to this is your instance, please. The instance is having a volume inside. You have created another volume outside. You want to take this volume that you have created from outside and bring inside here, right? That is what you want to do. That's what you are expected to do. So in order to do that, what are you going to do? First of all, you are first of all going to mount this volume from behind. You are going to mount this volume from behind to your instance. When you mount the volume from behind to your instance, then you can attach now the volume from in front, from the console. So you first of all mount the volume. When you mount the volume, then you attach it. Okay, let's go and see what we can do. This is our volume. Let's go to our volume, please. Where is our volume? Here is our volume. Now our volume is this 4 GB. We click on the 4 GB and then we go to actions, and then we first of all have to mount it, and then we attach in front. So we have to go inside our machine. We have to sign into our machine, please. We all know how to sign in using this method. I'm signing it using Git Bash. Okay. Wanted to bring it closer to you. All right, we have signed in using Git Bash. So the first thing we have to do is we have to see if we can see our machine, let's see if we can actually see our hard drive that we have just created. LSBLK will make us see if we can have the hard drive. LSBLK, that is a command. Now we created what type of a hard drive? This is 7.9 GB hard drive. That one is the one that is belonging to the root. And then where is our 4 GB hard drive? We cannot see it here. Our 4 GB hard drive is not yet showing here. So we need to first of all attach. Let us attach. Is a 4 GB. It is okay. It needs to be attached, and it needs to be attached to EBS 1. It is found in 1C. If your hard drive is found in a different availability zone from your machine, you will not see your machine here. Take note of this particular path, def/sdf. Take note of that. In Cameroon, the leader of the opposition party just died, and his party is SDF. So you attach from here. Okay, we have attached. When we attach now, we can go now to our background, and then we launch lsblk, and then we see now this is our hard drive. Now here you can see it clearly. This is our hard drive. Okay, now this hard drive, now like this, we need to mount it. If you don't mount it, you will not be able to use the hard drive. You need to mount the hard drive. Okay, so in order to mount the hard drive, we first of all have to do something. We have to create a file system, and creating a file system is some sort of like formatting the hard drive. Okay, we used to do some sort of formatting on the hard drive. How do we create the file system? We run a command. All these commands are found in your notes. Please don't worry. Okay, you will see your notes. If you want me to show you, you will see your notes. You see the commands are there. In order to mount, let me even use your notes. In order to mount your volume, this will be what the command that you are going to use. I just copy the command, but please don't copy commands and use. Try typing them. Okay, always try typing them. Now let us look at this part, def/xvdb. Why do they put def/xvdb? Because when we are creating, the file was created under def, and this /xvdb, where do we take it from? Look here. This is the volume, 4 GB. It is telling us that the volume name is xvdf. That is why here we have this command xvdb. So if you put xvdb, it will not work. Okay, you will have to change that D to F. So that is, I wanted you to be very dynamic in your notes. This is not what is this. You do not follow, but this particular model. But the model that you are going to follow in your notes is the model where you are going to create an EC2 instance, and when you come right down to the level of the volume, you are going to add another volume. In that way, the name will be like this. I'll demonstrate it for you. You see. So you copy this command, and we paste here. And then we change this B to F, because what we have here is xvdf, right? We change it to, we make sure that it is also xvdf, and then we are making the file system. Run the command. See, the command ran successfully, creating journal, writing superblocks, and file system accounting information. Done. Our file ran successfully. After creating our file system, what is the next thing that we are going to do? We are going to create a folder. Create a folder, right? Let us just go with a note. We create a folder called test. In Linux, we call it directory. So create a directory called test. Why are we creating this directory? We are creating this directory so that our volume that we created should come and hook on the directory. That is the meaning of mounting the drive. Make dir test has already functioned very well. ls, that is test there, right? Now, when we already have the test directory created, what do we do next? We now mount the volume. Next thing is to mount the volume. Don't forget that the volume is not B, it is F. So sudo mount def /xvdf and then the name of where you are mounting the volume. We now mount the volume, and in mounting the volume I'll have to change this B to F, right? When I change that, we are ready to mount the volume. Volume mounted successfully, right? Our volume has been mounted successfully. So we cd now into the test directory. Can we cd into the test directory? Yes. Can we create folders there? Can we create files there? Let's see, touch file 1, file 2, file 3. These are files that we have created. We use the touch command to create file 1, file 2, and file 3. Permission denied. Why did they deny permission? Can somebody unmute and tell me why they denied permission? Roberto, you already did this. Can somebody unmute and tell me why they denied permission?
We need to add the sudo.
Exactly. Great. Thank you very much. We are not in the root directory. We are not in the superuser directory. So when you are not in the superuser directory, you should always add sudo, and then now you can execute your command. I like that. I like that keenness. The xvd xvd, okay, f. All right, now we are expecting that it should mount. Xvd, they say mount, test mount point does not exist. What did I do wrong? Mount, let me see, xvdf. Let's try again. Sudo
2 times, I think.
Should be a typo. Mount def xvdf test. Why did it refuse? ls. What happened to my test folder? It disappeared. Okay, it shows that the test folder disappeared. No, but we are in the test. Okay, can somebody see why we are unable to do that? We are inside the test directory. Okay, did you see that? We are inside the test directory, so we need to come out from the test directory. You cannot be inside the test directory and you are mounting using the test. You will not see it. inside this test directory, what do we have? We do not have anything inside, right? So what should we do? We come out from the text directory and we go to the home directory, and then it's from here now that we launch our sudo mount dev xvdf, then test. We expect it to run now. Okay, it already exists. That means we have mounted successfully, mounted on home Ubuntu user test. Okay, if we have mounted successfully, then at least now if we run the command df to make sure that the volume is mounted, we run df -lt. Are we going to see our 4 GB volume? If we cannot see it, we have not mounted. Yes, we can see it. This is it, right? This is it here. Extension, because it is 4 GB. This is it here. So we have mounted successfully. All right. Now we know that this EC2 instance is having an extra volume. That means this volume like this has been mounted here. It is having an extra volume. We can also detach the volume from there and mount it elsewhere. Okay, in order to detach this volume, guys, what you need to do is you need to first of all unmount. We are here, we have mounted. So what do? You need to first of all unmount. How do you unmount? You unmount by just simply running an unmount command. There is an unmount command that you should run, and the command is sudo unmount sudo umount. Right, just simply run your unmount and then you remove your volume. Sudo umount test. As easy as that. You see, it ran successfully. It is unmounted, and for you to know that it is unmounted, run again df -L capital T. You will not be able to see that particular volume. Look at this volume here. This volume here, when we ran it before, we saw this volume. When we run it now, the volume has disappeared. That means you have unmounted it, right? And when you unmount it now, you come in front of your AWS console, you go to volumes and you detach. This is the volume. You come now here, refresh, come here now, and you detach actions. You detach the volume. When you detach the volume is again now free. It does not belong neither to any of these machines anymore. Okay, it doesn't belong to any of these machines. So where are we standing? We have successfully created an additional volume, an elastic block store volume. We have created files inside. We have mounted it to one machine. We have unmounted it back from that machine, and we can also mount it into any different machine that we want. Okay, you use the same method to mount it to any different machines. The notes are there with you, so you are going to follow the notes, and we are going to do practice and presentation by the end of next week. Again, If everybody is not capable of presenting and keep doing like Benz is doing, we are going to keep eliminating. If we eliminate and all of you are totally eliminated and I have my money and you are not receiving the training, I am richer. Okay, any questions, please? Any questions?
Yes, sir.
Yes.
I don't know. Is the commands, or I'll just need the commands like the one for AWS, Linux, right? For easy understanding.
You will need the commands.
You gave the commands for AWS, right? Linux.
They are still the commands. They are still the Linux commands. These are Linux. That's the reason why we did
There's a slight
Linux.
difference between Ubuntu. I'm saying because there's a slight difference between Ubuntu and the other one, right?
These are your notes. The commands are there.
Okay.
This is your notes, right? Look here.
Yes.
All the commands that I have used, all of them, they are found inside these your notes. All of them.
Okay.
When you take your notes,
And then again,
look at this. This is the command to mount, sudo mount. All the commands are found in your notes. Just follow your notes. Just follow your notes step by step, and then you go along. Just follow your notes step by step.
okay.
Yes. Now there is something I've done.
Again.
There is something I've done in this live training, which is not the way your notes are going to be explaining to you. And I know that a lot of you are going to be facing problems. Look at what happened. Let me explain to you before you go and start calling me and telling me that your own is not working. Look at what happened. In the notes, right? This is what I said. I said that in the notes, you are going to create an EC2 instance. You are going to create an EC2 instance. For example, I'm creating I'm creating an EBS2 with all the characteristics. Ubuntu, and then T2 micro, and then we take our key pair, and then we still further come down and we take our security group, Okay, look at what I wanted to show you. When you reach here, according to your note, this is what your notes are explaining. When you reach here, you are going to add another volume. Okay, if you want to follow alongside with your notes, when you reach here, you are going to add another volume. Are you seeing? You can add another volume of maybe 5 GB. Okay, and then you launch now this instance. When you launch now this instance, you will see that all the nomenclature of the additional volume that has just been added will tie with your notes. Okay, but in the live explanation, that is not what I did. I created a volume from 0 and then I mounted it. But in this one, you are going to create a volume alongside an EC2 instance, and then you are going to detach it from that, attach it to that EC2 instance. Because when you create it and add that volume like that, the volume is not added here. You are going to still mount the volume. All right, I was saying that when you use this method, you will be expected to create, you are going to create a new EC2 instance, which you are going to add another volume on it, this is the volume. The fact that you have created this EC2 instance and you have added this volume, it doesn't mean that the volume will be mounted automatically. The volume won't be mounted. This is the volume that you have just created now. This volume will not be mounted automatically. You will need to still mount this volume. The volume is attached to the instance that you have just created, but it is not yet mounted. So you need to mount it. Okay? You understand that when we created a separate volume, we had to mount it to one EC2 instance. We have to attach it to one EC2 instance before we mount it, right? Now it is already attached to this EC2 instance. Now you need to go to the command line and then you mount it. Is it understood? Is it clear, please? Is anybody having a doubt here? Because I know there is a lot of confusion here. I myself, I face a lot of confusion here. So I want this to be very clear.
Please, I'm not seeing the screen.
The screen was not on.
Yes, sir, I'm not seeing it.
Oh, sorry. Is it okay now?
Yes, sir.
Okay. As I was saying, the aspect of detaching a volume from one place and attaching it to another is actually very tricky. When you are going to create, this is the EC2 that we have just created. These are the two volumes. We created an EC2 with an 8 GB volume, and then we added a 5 GB volume, right? This EC2 instance has this 8 GB volume as its root volume. Now this 5 GB is the 5 GB that we added. The 5 GB is attached to this EC2 instance, but it is not yet mounted. Okay, why is it already attached? Because while creating the EC2 instance, we created the 5 GB, so it is already attached. If it is that we created the EC2 instance first and finished, and then before we ever created the 5 GB volume, we will have to first of all attach it to the EC2 instance before we have to mount it from the command line. Is it clear?
Yes, sir.
Okay. Anybody having any doubt about it?
So now the only thing is you only need to log into the machine and you mount.
Yes.
If at all you added the volume while creating the machine.
Exactly. If you added the volume while creating the machine, okay, then all you have to do is go now at the background and mount. But if you did not add the volume, if you created the volume separately before creating the machine, you have to first of all attach before you mount.
Okay, is it safe to say that when creating your machine or your instance, right?
Yes.
You can just attach the volume, then you mount. Also.
Yes, exactly. Exactly.
Okay.
And then there is a warning that you should never do in the industry. When you want to detach a volume from one EC2 instance to another, you first of all have to unmount it from the command line before you detach from the console. If you ever try and detach from the console when you have not yet unmounted from the command line, you are going to destroy the data of that EBS, and you are going to lose a lot of data. And you know, in this type of thing, you are being trained to be handling very sensitive information. So you should never detach when you have not yet unmounted. Is that clear? Never you detach when you have not yet unmounted. If like you have your EC2 sitting in your room, you want to remove the hard drive from that EC2. What do you have to do? You have to first of all shut down everything, right? You shut down your EC2, shut down everything, and then you unplug now the cables. Not so. Should you just go and unplug the cables when the machine is on? You might destroy the data, right? That is why you should always unmount from the background before you detach from the console. If you try and detach from the console without unmounting from the background, you might destroy data from the volume. Is that clear? All right, that is what we had for today. In the absence of any question, I believe we can end the session. And please do practice. Do a lot of practice. Do a lot of practice. Okay? Do a lot of practice. See you guys tomorrow. I'm going to make sure I update the notes immediately so that you should start doing practice right away. All right, good night everybody.